Hey everyone, and welcome back. Ready to dive into some seriously mind-bending stuff today?
Always up for a challenge.
Ah,
What are we tackling this time?
well, we're going deep into quantum singularities, water memory, bioelectricity, the whole nine yards.
Oh, wow.
Yeah, and the big question we're wrestling with is,
Yeah.
could all these things be connected? Like, way more than we even realize.
All right. I'm intrigued. Let's do it.
So we've got some wild research to dig through, even some math equations, but don't worry, we'll make it all make sense.
Okay. Sounds good.
All right, so to kick things off, let's talk about something I bet a lot of people have heard of. Water memory.
Okay.
This idea that water, even after you, purify it, could still be holding on to some kind of memory of whatever it touched before.
Right.
Is that just totally out there, or could there be something to it?
It's definitely a controversial idea,
Yeah.
but there's actually some science that might explain how it could work.
Okay.
You see, water molecules, they're super interactive. They're constantly forming these clusters and networks through these things called hydrogen bonds.
Okay.
And these structures, they can actually stick around for a while.
Interesting.
And some researchers think that's how they might hold on to information.
So you're saying these little clusters are like tiny little memory banks, each one holding on to a record of everything it's encountered.
Yeah, that's a pretty good analogy.
Wow.
And one of the websites you sent over, teleologico.com,
Yeah.
they go deep into this idea.
Yeah.
They talk about how molecular interactions and frequency resonance could play a role in water memory.
Okay, I'm listening.
Basically, water molecules vibrate at specific frequencies, right?
Uh-huh.
And those vibrations can be influenced by whatever they touch, whatever they've been exposed to.
That kind of reminds me of those cymatics experiments, where you see sound vibrations making those cool geometric patterns in water.
Oh,
It's like the water is remembering and reacting to the frequencies it's been hit with.
exactly. And get this, the wave equation, which governs all these standing waves, it shows us how they can actually amplify the structure
Hmm.
in a way that seems like it's storing information from those past interactions.
So the water's not forgetting as fast as we might think.
You got it.
Wow, okay, that's pretty wild.
Yeah,
So we've got these clusters potentially holding on to information.
right.
How does that connect to the idea of quantum singularities?
Well, think of those water molecule clusters, like tiny quantum singularities.
Okay.
They're like these super concentrated points of energy and information acting kind of like storage and processing units, but at the quantum level.
So now we're talking computers. These water molecules are sounding more and more impressive.
Mm-hmm.
But I gotta admit, I'm still not quite getting how it all works.
Okay, so picture this.
All right.
Each of these quantum singularities, even the ones that might be formed by those water molecules, has its own unique probability distribution of energy states.
Hmm.
It's all governed by a specific equation that describes how that quantum state evolves over time, and external stimuli, things like changes in temperature
Mm-hmm.
or exposure to different substances, those can actually change the Hamiltonian of the system.
I'm gonna be honest, you lost me at Hamiltonian.
Oh yeah, sorry.
No worries.
It's basically the energy operator, and changes to it, they directly affect how the singularity behaves.
So basically, stuff from the outside world is messing with the energy of these tiny quantum systems, and that changes how they act, what info they hold, all that.
Exactly. You're getting it.
So kind of like how a computer's hard drive, it spins faster or slower depending on what you're doing with it.
Yeah, that's a great way to think about it.
All right, now that's an image I can wrap my head around.
Perfect.
So each little water molecule cluster acting like a tiny hard drive, responding to the world around it. That's pretty wild.
It is, right.
All right, so my brain's trying to keep up here. We've got these quantum singularities, maybe even in water, acting like these little hard drives, storing information. But how does this all connect to us, to our bodies?
That's where bioelectricity comes in.
Okay.
See, our bodies, they're basically like walking electrical circuits.
Whoa, really?
Yeah, our cells, they maintain this electrical potential across their membranes, and it's the flow of ions, things like sodium, potassium, that creates all this electrical activity.
So we're like living batteries.
In a way, yeah. And this flow of ions is what allows our cells to talk to each other, to do their jobs,
Yeah.
And what's really cool is the potential link between bioelectricity and, you guessed it, quantum mechanics.
All right, I'm hooked. Tell me more.
So one of the sources you shared, the GuyFoundation.org,
Yeah.
they talk about research that suggests quantum mechanics could actually be influencing those bioelectric phenomena. It's a pretty new field, but it's pretty exciting stuff.
So are you saying our bodies are running on quantum power? Is that what you're telling me?
Let's zoom in on our cells for a second.
Uh,
Inside each cell, you've got these things called voltage-gated ion channels.
Voltage gated what now?
Ion channels, they were like these little gates that open and close,
Yeah.
letting those ions flow in and out, and that's what creates those electrical impulses we were talking about.
So like little doorways for the ions.
Exactly. And here's where the quantum stuff comes in.
Okay, I'm listening.
The opening and closing of these channels, some scientists think it might be controlled by, wait for it, quantum probability states.
Hold on, really?
Yeah. It's like each channel has a certain chance of being open or closed, and things like voltage changes or certain molecules, those can affect those probabilities.
So you're telling me that the electricity in our bodies, the stuff that controls everything, our muscles, our thoughts, all that,
Yeah.
it could be influenced by these tiny quantum
You
events.
got it. There's this thing called the wave function of ion transport.
Okay.
It's a way to describe how those ions move across the channels, and it suggests that even tiny little energy shifts,
Yeah.
they can change whether those channels are likely to be open or closed.
I'm starting to see how it all fits together. We went from water to quantum singularities, and
Okay.
now we're talking about bioelectricity in our own bodies.
It's all connected.
And it's all potentially linked to these crazy quantum effects.
Pretty mind-blowing, huh?
That's an understatement. All right, so we've got to talk about memory now.
Okay. Yeah.
Usually we think about memories being stored in our neurons, like files on a computer.
Right.
But you're saying there could be this whole other quantum layer to memory.
Exactly. Think of each neuron as one of those quantum singularities we've been talking about,
Hmm.
constantly interacting with stuff from the outside world.
Okay.
So every time we experience something new, learn something, even just think a thought,
Yeah.
those things, those stimuli, they could actually be changing the state of those singularities, almost like they're imprinting information onto them.
So instead of just signals going back and forth between neurons, it's like there's this deeper level of like quantum interaction that's shaping our memories.
That's the idea.
Like every single experience is changing the quantum landscape of our brains.
Pretty much. And you know how the connections between neurons, they get stronger over time.
Like the more you use them, the better they work.
Yeah, exactly. It's called synaptic plasticity.
Right.
Think of it like well-worn paths in your brain, making it easier for signals to travel along those routes.
Makes sense.
And some scientists believe this strengthening of those connections could be linked to these lasting changes in the state functions of those neuronal quantum singularities.
So learning something new, that could actually be changing the quantum states of our neurons, making those connections stronger.
Yeah, and there's actually an equation for it.
No way, really.
It's called the equation for long-term potentiation, or LTP.
Okay.
It describes how those synaptic connections get stronger over time, and it connects directly to the probability distribution of energy states within those singularities.
So even something as complex as memory, it could be tied to these quantum principles.
It's all starting to come together, isn't it?
My mind is blown. Okay, you mentioned external stimuli messing with those quantum singularities earlier.
Yeah.
Can you tell me more about that? Like, what kind of stimuli are we talking about?
It's not just stuff like light and sound,
What else could it be?
Everything we experience, every emotion we feel, even our thoughts themselves, those can all be external stimuli.
Whoa. Really?
Our thoughts, they trigger these electrical impulses in our brains,
Right.
which can create these electromagnetic fields that go beyond our bodies.
Uh-huh.
And those fields, they could potentially interact with the quantum states of everything around us.
Hold on. Are you saying that our thoughts could actually be affecting the quantum world outside of us?
It's a wild thought, right?
That's an understatement.
It would mean we're all connected on this quantum level,
Mm?
constantly influencing each other's realities.
Whoa.
But of course, this is all still very theoretical.
Yeah, I bet.
We need a lot more research to really understand what's going on.
This is a lot to take in. We've gone from talking about water molecules to like questioning the very nature of free will.
That's how these deep dives go. Sometimes you end up in some pretty unexpected places.
It's incredible how these seemingly totally separate ideas all seem to connect back to this quantum realm.
That's the beauty of exploring these big questions. It forces us to think outside the box.
So if we're all swimming in this sea of quantum possibilities, constantly influencing each other and being influenced, what does that mean for our sense of free will? I mean, if our thoughts can actually like nudge the quantum world around us even just a little bit, does that mean we're less in control than we think? Does free will even exist if It's all quantum mechanics running the show.
That is a question that's been bugging philosophers and scientists forever. Really gets to the heart of that whole free will versus determinism debate.
Yeah.
If our choices, our thoughts, everything we do is all being influenced by these quantum events, stuff we're not even aware of, does that mean we're just along for the ride? No control at all?
I'm starting to feel like Alice down the rabbit hole here. Are you saying free will could be an illusion?
Not necessarily. It's not that simple.
Okay.
Quantum mechanics, it doesn't totally wipe out free will,
Yeah.
but it does throw in this whole element of randomness, probability,
Okay.
It's not like everything's already set in stone, decided from the beginning. There's still room for us to choose to act on our own,
Okay.
but it all happens within the framework of these quantum possibilities. That's the key.
So it's like we're playing a game, but the dice are loaded.
Yeah, I like that.
We can make choices, but the odds are already kind of tilted by these quantum states we can't see.
That's a great way to put it. We might be able to influence which of those quantum possibilities becomes reality through the choices we make, but we don't have total control over the probabilities themselves.
So it's this weird dance between chance and choice, between the quantum world and, like, our everyday lives.
Exactly. It's a lot to wrap your head around, that's for sure.
No kidding. We've gone from water molecules to questioning the very nature of free will, all in one deep dive.
It's amazing how it all connects, isn't it?
It is. It's like all these different ideas, they all lead back to this quantum realm.
It's the beauty of exploring these big, mind-bending questions.
Yeah.
It forces us to confront what we don't know, to embrace the mystery.
All right, so let's try to sum this all up.
Okay.
We started with water memory, the idea that water could be holding on to information from its past, right?
Right.
Then we talked about bioelectricity, all that electrical activity that keeps our bodies going. And we learned that both of these things might be connected to quantum singularities, these tiny points of energy and information that could be way more important than we ever thought.
And to make it even crazier, all that external stimuli, the light, the sounds, even our own thoughts and feelings, they could be constantly shaping those quantum states.
Yeah.
It paints this picture of a universe where everything's connected, everything's changing, constantly evolving.
And that brings us to our final thought-provoking question for everyone at home.
Let's hear it.
If the universe is this huge network of quantum singularities all interacting with each other, shaping and being shaped, what does that mean for us? For who we are, where we came from, where we're going?
That's a question each of us has to wrestle with on our own. But one thing's for sure, this journey of discovery, it's only just begun.
That's another deep dive in the books, folks. Thanks for joining us on this wild ride through the world of quantum possibilities. Keep those brains buzzing, check out the sources we talked about, and until next time, keep diving deep.